What's up, guys? This is the Desmos Visionary. I don't know if you've ever played the Guess the Function game, but it is a game that I thoroughly enjoy. And here's how it works. So, we have a table of values, and normally you get people to guess the function. And lots of times these functions are super easy, but I like to make it really challenging. And this is a wonderful set of data that is actually pretty difficult to come up with a function for. So normally you could just use x, and all of these data points would line up with y equals x, except for this one, 4, 5. That doesn't line up with everything else that's on this table. And so the question is, how do we go about doing that? I have a function here that actually follows that. And I'm going to explain to you how I get there. So it all starts with x and this little function here. This function has a little hump in it, and that's exactly what we're going to use to try to get this function to jump up just at that value of 4. So the thing is that we've got this hump, but if we just add it to x, then the rest of our values aren't going to line up, and it's not going to jump up in the wrong place. So what we have to do is use the floor function. And when we do that, then we get this one point here at 0, 1, and everything else is 0. Which is good, that's kind of what we want. But it's just one point. And you can see why this is happening if you graph this and y equals 1. This graph goes over this one line. It only meets it, it doesn't go above it. So only that one point is at a 1, and what the floor function does is it takes everything in between here and makes it a 0. So this function is 0 for everything except for that one point when you apply the floor function to it. And I want to make it so that it's a little more clear. If you add a 0.1 to this, then it kind of spreads out the area that exists for it. You can see it intersects it there, which means that whole section will become a 1, and everything through here will become a 0. So we apply the floor function to that, and it's pretty exciting. Now it's just a matter of moving this hump over to where 4 is, and we're going to do that by subtracting 4 from x, which moves it over to here. And then all we have to do is add x to it. And look, that is our function, which is pretty awesome. Yeah, pretty difficult to do. Here's where it gets interesting, because some people don't like it when you play this game and have a non-continuous function. Well, let's be honest, a lot of people don't like it when you play this game and bring in the floor function anyway. But they don't like it when it's continuous, when it's not continuous like this. So I challenged myself to find a solution that was continuous. And here's what I got. Whew. There's a lot of things in here. Let's make these all disappear. Look at that. It's a function that's continuous, and it hops up right there at 4, and we have 4, 5. That's pretty neat. I'm going to tell you how we got there. So we have this function. Wow, isn't that neat? What we're doing here is we're taking the absolute value of x minus 4.5, and then we're subtracting x plus 4.5. Now past this point at 4.5, the absolute value of x and negative x will cancel each other out, because we have a positive x and a negative x. And so we just have 0 past this point. And before this point, we have a line with a slope of negative 2x, because we have this absolute value of x, and then we subtract x, and so those will add together when they're below this point. Because we're taking the absolute value of the negative number, and when we do that, it becomes positive when we add that together. Basically, the thing that you need to notice is it's 0 for this side, and then it's positive or non-zero before it hits 4.5. we've done the same thing with this function, except at 3.5, and we've changed the sign here and here so that it's oriented this way instead of this way. So it's 0 before it hits 3.5 and non-zero afterward. And if we do it like this, we can multiply them together and get this nice, neat little hump. And what's really notable about this hump is that at 4, it equals 1. So now, since it's 0 everywhere else, and 1 at 4, we just add it to x, and we get this wonderful function that satisfies every value in the table. Now that's an awesome solution. And I encourage you to go play the Guess the Function game, but I especially encourage you to break out these fun functions because they certainly make the game very interesting. I'll post this Desmos graph in the description, and I encourage you to go play with it yourself. Thanks for watching. I'm Philip with the Desmos Visionary.